So I go now?
Yep.
Cool. All right. Hi, everyone. Welcome to the first Water World community-led event for blockchain coding. Um, so I am TDH, and I am going to take you through. I and Pokey will take you through this series of sessions on blockchain coding. So blockchain development, Web3, blockchain stuff. And so throughout this series of talks, everything is going to be on my GitHub, which is here. So every session will have all the materials here, which you can then download. And I've got a README here so that you can follow the different steps. So I'm gonna go through kind of everything, like back to basics. Some of you might already have Python or Git, but this is for those who are new. Um, So you're going to want to download Python. Anaconda is pretty good. They're one of the more popular distributions, and they'll have quite a lot of stuff you need. So download Anaconda, um, install it, and then you're going to be able to see the Anaconda prompt in your start menu. We're going to use this a lot. Um, uh, and for um, if you want to be able to easily get the code from GitHub, uh, you should get Git. Now Git, there's different versions available. So I use Tortoise Git. The reason is because it's nice and easy to navigate. It's all context menu driven, so you can navigate through folders. And so what you would do here is you would go to your documents or wherever you want to put the stuff. Hit Git clone, and then you want to paste in the link from here. This link here. So when you paste that in, it's going to pull down all the code from my GitHub. Um, so then once you have that set up, um, just a few things to do. You want to with Python, Anaconda comes with a bunch of stuff, the really standard stuff. But one of the nice things about Python is that there's a whole ecosystem of third-party libraries you can use. So we're gonna in this first session use Web3, which is really commonly used for Web3 stuff. And Morales, who are a third-party API provider. So I'll be going through those guys uh, in the notebook. So notebook, you're going to see in a second. It's one of these kind of standard ways of looking at Python code. The nice thing about Jupyter is that everything's laid out in a nice way. I can put text and images and code, and it's kind of nice if you want to draw, charts and stuff. Later on, you can see some charts. And it's quite easy, it's already easy to navigate. So yeah, so once you have these guys installed, you just navigate to the folder where you pull down the files, and then type in Jupyter Notebook, and that's going to load up in your default browser. Um, okay. One more thing is that um, in in this code, we're going to be using some API keys. Um, Now we don't want to put these on GitHub, so you're gonna you're gonna get your own, and these are all free. You can set up your own API keys through these links. And now what we're gonna do is you're gonna put them in a .n file. .m files are invisible to Git, but it's gonna be where you put your keys, so it doesn't get put into GitHub. Okay, so that's all the setup stuff. Let's head on over to the notebook. Yeah, so I won't go through this first section here. Um, yeah, if anyone wants me to revisit this stuff in a later session, just let me know. Let me know, and I'll go through it again, or I can focus on bits that you don't understand. But yeah, the links to the Ethereum docs and the white paper are all here, So just go ahead and have a look at those. We're going to look now at kind of how we interact with the Ethereum blockchain. So as you might know, um, Ethereum is made up of lots of nodes running, um, and Ethereum provides, the EVM, which is like a kind of a centralized stateful machine where we can execute code. But everything is obviously decentralized, so everything's run across the network via nodes. So typically, if you want to do anything, read or write, you're going to have to interact with the node. Now, you can run your own node on your machine, um, but most people will just use a third-party provider like Alchemy or Infura. So these guys allow you to query, either read or write to Ethereum or other networks they support. Um, you can do that using just an API key, which you got in the previous step. And once you have a key, you connect to the WebSocket provider, and then um, you have loaded um, the provider into your Web3 library. And once you have that, you can basically, through this W3 object, you can actually query the blockchain. So you can ask, what is the latest block? So here's the latest block. What is the hash? Some of the things. These are all the things that were included in that block. All this kind of stuff. So there's a lot you can do. Obviously, I'm gonna go through a really simple example today. Um, Nothing fancy, but we can expand on. We will expand on this next month. We're gonna start, interacting with the blockchain, submitting transactions. So that's gonna be more involved. But for today, we're just gonna go through reading. So I picked the wild contract. That's a nice one to start with. Um, Now, one thing I want to talk about is the idea of a proxy contract or a delegate. Um, so if we go to the wild contract on Etherscan, you're going to notice we're going to go to so this is the wild contract. You can see wild here. You can see the it's marked in Etherscan as a contract for tokens, which means ERC20 basically. We'll go through that next month in more detail. But what you're going to see also is that there are two contracts. There is what we call the proxy contract, and then there's actually the underlying or the implementation contract where all the code is. So the first question you're probably going to have is, well, why are there two contracts? Well, the reason is that on the Ethereum blockchain, contracts are immutable. Excuse me. Excuse me. Which means that once you upload a contract, um, it can't change. So it's kind of good and bad, right? So we want to be able to upgrade contracts because there might be bugs, or we might want to put new features in. But it's a bit tricky if contracts are immutable. So what is commonly done is we have what they call a delegate pattern, which means that the proxy contract is the interface basically, and it says the same. It's forever the wild contract, but it delegates calls to an underlying contract, and that typically Etherscan will mark that here. So if you go to the contract, you ever see tabs for as proxy, that's telling you that this contract is a proxy and that the actual code is here. In fact, you can see that this is called the zero DAO token, right? So this is actually the source code, and here actually is in the contract the actual stuff for the wild token. So some of these functions are like balance of, decimals, name. Um, Now some of these, so these won't be visible here for some of the values because the proxy is what is initialized. So here you'll see the name and the owner symbol. So think of the proxy contract as the interface, and the kind of the implementation contract as the underlying code. So we need to know this for two reasons. One is that you want to know where the code is. Secondly, we need to know what the ABI is. Now, the ABI is the application binary interface. This is basically information that tells us what are the functions exposed to the blockchain and what are the parameters. Because if you're gonna make calls to this contract, you need to know what the function is called and what the parameters it expects are. An API, it looks a bit like this. Um, it's basically a JSON file with lots and lots of functions. Um, so okay, so you can see balance of here, for example. Balance of, you can see that has stuff like the outputs, the return type, um, has stuff like non-payable. This means that the function is not designed to move ETH around, that kind of stuff. But the ABI can only come from the implementation contract because that is where that's where the functions live, right? So that's why we need to know that if you're going to ask Etherscan for the ABI, you have to use the implementation contract here, not the proxy. Okay. But that being said, Etherscan has a really cool way to just download the ABI via a URL. Basically, it's a REST API. So if you put this into your browser, you actually see the same information. Now, once we have the ABI, we can load it into. We want to open the URL, right? So we're gonna use the URL lib Python library to load, and then we're going to pass it into the JSON Python library. So this is basically a very standard Python library, which takes in a string that is in JSON format, and then it creates a JSON object, which means it's easier for you to manipulate the data. Basically, you can do stuff like this. Basically, it's a nicer way than having to parse the string yourself and make it readable. Okay, so we have the ABI JSON. Now we're going to pass it into the Web3 instance, and this is basically saying I'm going to create a contract. The address is no, it's the proxy contract, and the ABI is what we had from before. So at this point, this object is the wild token contract. So now you have available all the functions the contract has here. So let's just now we can just call a few simple ones, just to show that we can read the contract. So this contract is useful, and it's going to be useful next sessions when we start to look at how to push, how to send information, how to create transactions, basically. Okay, so I think that's everything. Yeah. So we're gonna move on to to using Morales. So one thing you'll notice about contract is that they are kind of state bound in the sense that you can read stuff as of now. So balance of at this point in time, or this is supply right now. But we can't through this interface get all the data from the past. So we can't read here what the balance of somebody was, last month, last year. Now the information is all available on the blockchain because the whole point of blockchain is that it is public and readable. The data is there, but it's just what is an easy way to get that data without having to, go through all the blocks one by one. So one nice way is to use Morales. So they have like a kind of like a third-party API, um, and their API has quite a lot of cool stuff. So we're going to look briefly today at the token API and the NFT API, but you can see that you can get lots of stuff. Transfers, balances, price. We're going to look at holders in a moment, but you can get metadata as well. And there's some generic stuff you can get as well. So it's pretty cool. You can get a free API key. Um, there's limits on how much data you can request per day or whatever, but for most of us, it's more than enough. Okay, so what we're gonna do is basically we're gonna use the this guy. So this guy basically is saying we want to get the price in the past. Now, but what it needs though, it needs information in terms of block number. Um, you'll see that every we see the block numbers determine kind of the block in which something was done. So there is there's not a I mean the way if you have a date in mind, um, is you can work out the block. What I've done here is I've just picked a block that happens to correspond to last August. And there are roughly 7,000 blocks a day. The number does change with time, but you know, basically, roughly about a month worth of data here in these two blocks. So we're going to pass these two blocks into the this for loop here, so that it's going to loop from start to end in increments of 7,000. We've passed in the wild contract here, got part the API key. So once you do that, you see that it gives back all the data you need. um, Not very readable, right? So we can use another built-in Python library called pandas. So pandas is very, very widely used um, sort of data handling library. Um, One of the most commonly used objects is the data frame. The data frame is like think of it as a big table, um, but they're very powerful because you can transform, you can add dimensions. In this case, we just want to load in this JSON formatted string and then produce a table. So here you see all these JSON blobs are kind of put into a readable form. And we're looking at the USD price in particular here, but there's other stuff as well. So all this kind of stuff here. And it's kind of nice that you can just do a really simple plot using a data frame. One of the many things that you can do very easily with data frames. It's not very pretty, but it's kind of a basic idea of the price. Cool. And so we did have a quick peek of the NFT API. So there is also a way you can load holders. Um, Now, I'm going to explain why this is useful. Excuse me. Now, NFT contracts. You might be thinking, why can't you ask the contract to give you the list of all the holders? And the reason that you can't do that is a little bit subtle. So the reason is that in the source code for typically for ERC 721 NFTs, there's almost always a contract, function called what's it called? Owner of, yeah. Or- So owner of, if you give it token ID, it'll give you the owner. Um, but you need to know, so you can't reverse engineer it. So you can't ask it to give you a list of owners because this is a one-way map basically. Um, and most of the contracts written have don't have the ability to iterate over the values. So it's kind of nice for you to be able to get it through an API. So here we're asking for owners of, this is the season 2 kicks. So you can see in the data we get back that we have 100 results. So there are more, but I've just set them to 100 for now. And you can get for each one, you get top 100 or the first 100 kicks. So you can see, here are the names of these kicks. Some you can get all the metadata as well, so it's quite handy. And you can see that it has the owner as well. So these guys, these are the owners of the contracts here. Yeah. So that's kind of a quick run through of the Morales API. So that kind of does it more or less for today's content. For next next month session, we're going to look a little bit more closely at the ERC20 contract. So how to create your own token, basically. We're going to go through, the basics Solidity, because we're going to have to write some Solidity code. We'll go through how to compile it locally, how to compile it and how to check that it works, and then how to submit it to testnet. So all the stuff will be in my GitHub. We'll go through all that stuff. And yeah, if you have any questions in the meantime, just ping me or send me a DM. And that's it. Thanks.